Okay, so what I've done is I've made 2 vertical alignments on a little piece of access road. This actually did come from a wind farm in northern Vancouver Island quite some time ago. I'm assuming they actually developed it. You can see the faint yellow lines in the background. That's the road they gave me. Anyway, so I just took a chunk of that and optimized it. And I threw in a little bit of rock in there. So let's just see how I did that. First of all, well, let's look at the subhorizons first. This is probably where you want to start anyway. In the event that you have something less than a simple single layer of material, you can put multiple layers in here. So I've put in overburden for 0.3 of a meter, glacial till down to 10 meters, and then solid rock below that. This is just an estimate. The fact is we're never going to cut deeper than 10 meters anyway, so probably it's irrelevant what's in the third layer. But I only did that for the first 2,000 meters, and then after that, I pinch out the glacial till layer and bring the rock right to the surface. And as far as the Opti-Haul is concerned, it's you may as well just take the glacial till right out. But there's other reasons to leave it as 3 layers. I am not even sure if I can remember exactly why, but there's 3 layers. One of the layers is 0 thickness. Let's just look at the helper for that. So if you don't want to type in a string, you can just put in your depth. First you put your materials, and then you put your depth. So if there's no depth here, well, wait a minute. If there's no material here, then you can't put in a depth. So this is like overburden, and then 0.3 meters down, it switches to glacial till. If I put a third layer in, then I can say, okay, how deep does the glacial till go? It goes down to 10, and if I put in 0.3 like I did, that essentially says that there is no glacial till. It's just overburden switches to rock at 0.3 meters. Because these are depths, not thicknesses.
What is the overburden?
Generally topsoil, duff.
Okay.
It's going to be stripped off. So let's take a look at that. Site preparation, this is where you do your stripping, and I apologize for this dialog box. It's one of the most unfriendly dialog boxes we have in the software. Essentially, to put in stripping, you look at this little group box here, overburden removal. You put in a depth, and you choose how it's going to be removed. So on the inside of the lane, we'll start at the center line, both sides. And then outside, we're going to strip until we hit the edge of the slope stake or catch point. And then we're going to go an extra meter. Okay, and I click on Add Edit there, and it puts it in here, and you can't hardly tell what it means, but you can have different station ranges and different stripping. Okay, so so that means that the cross sections are going to look like this. Now this cross section is in the rock section, and you can see out here where there's no stripping or cut or anything. It's just 0.3 meters, and there's something on top and there's something underneath. If we look at the actual cut, it says here we're cutting solid rock. We would be cutting overburden, except it's been stripped off. You see the little line here? And so in fact, we don't need to cut to the old surface of the ground because it's already gone. So we just cut up to the depth of stripping. Similarly, if you had some fill, if I just go into the template editor, you know, it fills it down to the stripped surface because it can't fill on top of the overburden which has been removed. Okay.
Then that black line there is to the extra meter, right?
That's right. That's the extra meter I specified in my overburden removal. Okay,
Yep.
and let's just take a look now a little further back. So that's in the rock zone, and here in the other zone,
Excuse me.
there's my interface between glacial till and rock, and if I hover on here, it now says that we're cutting glacial till GT. Okay, so I've basically made this stuff up, hopefully in a real situation. This is coming from LiDAR data, so there's no ground type information. You'd have to go out there and walk around a bit to figure it out. And I just made this up to make it interesting. Right, so then the other thing you do with materials is you assign, okay, so we got site preparation, we got subhorizons, that's layers under the ground, and finally fill types. What are you filling with? And from the optimizer's point of view, it needs replaceable material. In other words, if I said we must fill with glacial till, what would happen if it was cutting rock? It would get stuck, right? It would have to pile the rock in a pit and find glacial till somewhere. So we came up with this idea of quality-based fill materials, and you can choose a material for fill, but you're actually choosing a quality when you do that. So if I choose glacial till as my fill material, it's quality 2, and that says anything quality 2 or better is acceptable for fill. So when the Opti-Haul does its optimization of material movement, not the vertical alignment is sort of another problem. It happens at the same time. But once you've got a vertical alignment designed or optimized, the material has to be moved back and forth. And it figures out the cheapest way to place all the fill that it needs and obeys these rules that it must be quality 2 or better. So in this case, if we cut solid rock somewhere, we can use it as fill because it's quality 4, better than 2, that's okay. Right, so we've assigned the same material everywhere, or at least the same quality everywhere. Good. Oh, and I chose a template here. We're just using the same template everywhere, but I chose a template that I thought was kind of applicable to your work. It's just a simple one-layer, gravel surface road. I haven't bothered to make any super wide spots for those transporting of the actual windmills and so on, but I think you'll get the idea. Okay, so I did the optimization, and now we've got a vertical alignment. Here it is, and there's an interesting spot here where the ground is too steep, and so we had to do a little bit of cut on the top and some fill down at the bottom to make up for the very steep alignment. And this is what the mass haul diagram looks like. The mass haul diagram currently, oh, it says here it's out of date, so I can fix that by just doing a recost. That's the recost button there. There we go. Now, the mass haul diagram, as we've seen before, has this option for use Opti-Haul volumes. So I'm going to turn that on. It doesn't make much difference in this case, but it can make a difference. I'm wondering why that was turned off to begin with. Huh. Anyway, it can make a difference if you've got fill material getting replaced. And the old mass haul, we kept it in there just because, as I mentioned to you, if somebody opens up a design that was made in version 7 or version 6, we don't want them to see their mass haul diagram change from the one they printed out. So we've kept the old mass haul diagram, which is with the Opti-Haul volumes turned off.
Okay.
But going forward, you should probably always have that turned on. Right, so you can see what the mass haul diagram looks like. This particular alignment has a pit in it, and I don't know if you've been using this diagram up here. This we call our Opti-Haul diagram. Are you familiar with that one, Casey?
Haven't used that one yet.
Okay, so if you want to use it, you go into Profile Options, and you add the OptiHaul graphic using the Select button here. So here's all the graphics you can put underneath. Often there's a mass haul by default. OptiHaul can be added as well. I put it on top of the mass haul. And what the OptiHaul graphic does is it shows you another way of visualizing the mass movement. And instead of showing you the accumulated mass, it shows you the quantity that's being moved past a point. So in this case, when I hover over that yellow one, it's glacial till is being moved from left to right, and it's 1272 cubic meters being moved. And the green one is 1867, and you can see that it's just a little bit thicker. So the actual quantity depends on the thickness. So here I've got a whole bunch of material being moved. 2,700 cubic meters are being moved. This little symbol here is a pit.
Mm-hmm.
I did create a pit for this design. It's at station 2500, so pretty close to the end. And it's a pit that has glacial till in it, and the capacity is infinite. If I had chosen the smaller capacity, it may have run out of material, and we'd get a slightly different optimal solution.
Is there a way to change the material from glacial till to what the nomenclature is, you know, in other parts of the...
Oh, totally, yeah. That's all your ground types table. So I press on that button there, and you can add and remove as many materials as you want. So I can add a new material here, and you choose your own, actually defaulted the wrong. It's not a very good term because it kind of reminds you. Anyway, I don't know. So you come up with a name.
Yep.
Composite material, I don't know if I want to go into it here, but the concept is that if you pick a composite material, when you select this, let's call this, I don't know, real rock, something silly. You have to add other materials to make up your composite. Actually, I probably should have called it something that made more sense. So let's call this CP for composite, and oops, I forgot to, I think you have to do it when it's new. You can't do it later. Click on the composite material, and then you can choose what materials are actually in there. The concept is that you don't know where the layers lie, but you know that on the average you're going to have some, I don't know what you would call it. What's the kind of material you might have in your area?
I mean, we just refer to it as embankment, you know?
Yeah, okay. But anyway, for this composite, I'll say that we have, on the average, 50% gravel and some rock in the ground too. And you can put up to 3, I don't know how many you can put in there, lots. Anyway, it has to add to 100%, obviously. But what's going to happen now is if you cut any of this stuff called C2 comp, it's going to be half rock and half gravel. Quite useful in some situations. Okay, I'll just cancel out of here. Point is, you can change your material types to be any names at all and any abbreviations, and
Gotcha.
and you can change the properties. One of the properties that's important is your expansion compaction. I'm not going to go into that here, but these are multipliers. So
I know what those are.
good. Okay, let's go on to the Opti-Haul. So this shows you the material being moved, as does the mass haul diagram. But when you start getting multiple materials, the mass haul diagram gets a little bit fuzzy. It is possible to change the mass haul to show only one or two materials. So I could go into cut materials here and say, you know what, I only want to see solid rock cut, and I don't want to see the rest of it. And I could build a mass haul that just showed me solid rock. I'm not going to do that. The Opti-Haul diagram automatically shows you all the materials. At least if you hover it, it does. So there we're moving two materials at the same time here. If they were going in opposite directions, which is possible, it would make two little graphs there. And the other thing that I really wanted to get into here is that this representation, which I think is quite valuable, I think it intuitively shows you what's going on, can also be printed out as a table. Before I do that, let's look at a completely different design. So I'm going to set this one current. It's recosting because it wasn't when we opened it. And, oh, that's funny. What's going on here? Recost. Okay. Oh, yeah, I don't know why it wasn't showing anything for a minute there. Okay, so this is obviously a completely different design. And the only difference is I took the pit out. So now it's forced to, first of all, it's forced to balance, and you can see that it does balance. This was optimized, so that's why the alignment is perfectly balanced. It's also got a different flow. It's moving all the material to the from left to right, which is kind of nice. There's a little bit of backwards material movement here. Come on, show me. I guess that's going forward. There's the backward stuff there. Yeah. But clearly the choice of having a pit or not having a pit makes a big difference to what the Opti-Haul calculates in terms of material movement. It has to balance all the materials, not just the gross cut and fill. It has to balance cut rock, cut glacial till, fill glacial till.
Let me ask you this, is that red half moon, is that telling you that's where they would recommend you put a pit?
Actually, when the software finds the vertical alignment, it's using a slightly lower resolution or slightly different resolution than what we're doing now with the recost. And the fact is there's a little bit of material left over. No, it's short of material, but it's a tiny amount, 61 cubic meters, and that red pit is what we call a overflow or underflow in this case pit, meaning that we tried to balance it but failed, and this is how much material you're going to have to borrow, and it's automatically put in a borrow pit, an emergency borrow pit, just to deal with it. So it's not really recommending that you put the pit there. It will put one at each end if it needs to.
It's just letting you know that you need a little something.
Yeah, you need a little something, but it's such a small quantity that really the problem here is in the noise. It's the whole thing is digitized anyway, You know, we're taking samples, we're doing average end areas, so there's little differences between the optimization, which found the vertical alignment, and the recost, which is double checking the cost and the volumes and doing the Opti-Haul at the end. Anyway, so it's an artifact, and you can ignore it if it's small. If it's big, that indicates that you do need a pit.
Okay.
And yeah, in this case, I mean, we're talking thousands of cubic meters, so 61 is not important. If it was 6,000 or 2,000, I would say, yeah, you absolutely have to put a pit in, and you should find a good spot for it. Right, and we can do a little comparison here. I don't know if you've seen this before. Compare with current, so you can see that there we go. So with pit, the total cost is $78,000. Without pit, it's $89,000. That you'd expect that. It wouldn't use the pit if it wasn't cheaper to use the pit. And the difference is an awful lot of the difference is coming from the haul. Material doesn't have to be hauled as far if you use a pit. But there's also cut and fill differences too. And, yeah, it's interesting. It's interesting how it works. You can take it apart and figure out exactly why it did what it did, and occasionally you scratch your head, but most of the time you can say, oh, okay, I would have done that too if I'd thought long and hard enough about it. Yep. Okay, so now let's take a look at the output to a table. So copy to clipboard. I'm going to include all the summaries and forget the details. Well, maybe I'll throw the details in the first time just so you can see what it looks like. And I need to open a spreadsheet. Okay, so Control-V paste. And here it is. So there's a lot of table information in here. This is the movement details, and it goes on for quite a while. Going over to EY, so yeah, lots. E times 26, whatever that is, number of columns. Every single, and we use this mostly for debugging, every single movement and cut and fill is somehow stored in here. So that's kind of, well, I won't say it's useless, but it's kind of useless for you. And here's the one that I wanted to show you, the detailed movement summary. And this is actually a copy of this, except in a table form. So it takes each of these lobes, like starting from here, we're getting well, let's look at the yellow one. Starting from here, we've got some cut, because the material being moved to the right is getting bigger and bigger and bigger. And you can see in the mass haul it's a cut. And then at this point, we're just moving material. And the reason it's yellow is because we're in overhaul. It's moving a distance bigger than the free haul distance. And then here it gets narrower, so there must be some fill, and you can see the fill in the mass haul diagram. And then it moves some more material, and then it dumps it out here. So we can look at that in the spreadsheet. Now, one of the problems with this is that it's too detailed. So we've got 6.2 cubic meters moved from 1610 to 1640. Okay, so first of all, that's a very small quantity. Second of all, it's not moving very far. So I'm going to recapture this stuff with some filters on it, so it doesn't give me so much information. Okay. Right click, copy to clipboard. This time I'm not going to include the details, and I'm going to say that I don't care about anything less than 100 cubic meters, and I don't care about anything less than 50 meters. Let's see what it does. What it'll do is it'll concatenate or combine things that are in that zone, in that range of. Let's just delete this and paste. Oh yeah, I knew that. There we go. And now you see there's less information, but probably more useful information. So that yellow lobe is overhaul, and it's broken it into 2 chunks. Well, 4 chunks, sorry. So each one of these you read, it's got a volume, and then a cut zone. So in this case, we're picking up material between 1530 and 1580, and then a fill zone. We're dumping it between 2070 and 2080. It's overhaul because the distance between those 2 ranges is bigger than the overhaul distance. And this is the average distance. And if you were to take that average distance and multiply by this volume, it would give you an estimate of the cost of moving that material. Okay. Free haul means that it's a short movement, and often you'll find that, and these are all pushed. Here's a pull. Pull means it's going the other way, so the cut numbers are actually bigger than the fill numbers. Free haul means the distance is small, and often you'll find that the cut from to is like oh no, they're not in this case. Let's see if we can find one. Yeah, here we are. So in this case, we're cutting up to 1940, and we're filling from 1940 onwards. That's pretty typical free haul movement. Some of the material isn't moving any distance at all, but on the average, moving that distance there. So I've seen people use these numbers to actually make a bunch of labels that go on the profile that say, okay, we're moving this material from here to here, and they put in the station ranges and the material types. Of course, you can just print out that spreadsheet or clean it up so it looks a little nicer. Yeah, so that's kind of the most detail you can get out of the software in terms of material movement, because when it does this Opti-Haul and it calculates your costs, it has to balance every material, and it has to move every material from where it's cut to where it's filled. And if it's going to do all that stuff to come up with a cost, we might as well give you the details, and hence this table. There's other stuff in there too. I don't know why I pasted it so far down the page. For example, the cost in dollars, volume summary by material, cut, fill. We don't have, oh, here's our underflow pit at 61 meters. Let's see what the other design looks like. So I'll go to this one, set it current. And copy clipboard, leave all the settings the same, and paste it in sheet number 2. So we have a pit, and it's at station 2500. It's right on the road, and we're cutting this much material out of the pit, 6,000 cubic meters. And here's our haul summary, and you can see that now we've got these movement from pit options on the left here, on the right here. So most of it's free haul, but there's a little bit of overhaul. The big difference between this one and the other one is there's a lot more overhaul. Probably more rock cut too, but there's a lot more overhaul in the design without a pit. Whereas here it's almost all freehaul. There's a little bit of overhaul, but it's small quantities. And you can see that too, of course, if you just look at the values here. The yellow is thinner than the green, where it was the other way around in the other one. Now, did I answer all your questions, Casey?
Yeah, I think so. I'm thinking about deliverables. You know, the table is nice. I like that. This screen here is nice too, because a contractor can look at that and go, they completely understand this. And then if you have the table to go with that, it's just going to be very valuable for them. So how do you capture this print?
Oh, good question. Okay, so we know how to capture the table. It's in the spreadsheet, and you can print that, and you can clean it up and make it look pretty too. But if I want to print this screen, first of all, I can just print it, but almost nobody does that anymore. If I just go to print here, it will print the profile window. But almost everybody will be working now with the multi-plot window. So first of all, you want to set up some options the way you want to see your windows, whether you have labels on here, various things like that, because it's a printout. And then you go into multi-plot and you add various windows. So for example, I'm going to add the profile window. There it is. I could put in a plan window here if I wanted to, and I can add all kinds of other things too, like for example a title block. So a rectangle is just literally a rectangle where you can either type or not type. You can also put in predefined text. And you can control things like font and so on.
Sure.
Okay, so it's basically a paper space piece of software that allows you to build a title block, to build graphics. Now, this is automatically printing 2 pages. So page 1 looks like this, page 2 looks like that. You can control how big your pages are. Whoops, that was a double click to show the profile window options. But over here, I got pagination, and in the multi-plot ribbon, I've got pagination as well. Pagination. You can choose what your page size is.
Okay.
You have to make sure that when you print, you use the same page size.
Right.
Pagination, here we are. So this is my design range, and I'm just using planner profile width, so it's going to fit on the screen exactly 1 per page. But I find what's best to do is figure out how big your planner profile is by clicking here, and then go back and choose something that's a little bit smaller, say 800 here. And that gives me page 1 with a little gap at the beginning, and page 2, whatever. If it got close to the end, it would make page 3, etc. There's a lot to the multi-plot, and I recommend you look at some of our videos on setting up the multi-plot.
Yep.
But the real short story is you set this up the way you like it, and then you save this in a tiny file called a book template. It's a BLT file, and then you reuse it. Different designs, you can use the same template. Have to be a little bit careful that when you create something, you don't have a page selected, because if you create something in a page, let's put in a scale bar. It has this little green triangle in it on the top right, and it's only visible on that page. If I go to page 2, it's gone.
Gotcha.
So when you create things that you want to see on all pages, you create them with the chapter visible. So it's book with chapters. You know, like you might have a title block chapter with just an overview plan or something, and then you might have profile chapter, and you might have section window in another chapter, things like that. You can add chapters, duplicate chapter, or add chapter. Yeah, that's the short story, but you can make it look as pretty as you like.
Sure.
And I think you'll be pleased with it. Yeah, if you wanted to put the spreadsheet on here on the same page, it's a little tricky. It is possible, but I would recommend that you just print it out on a separate sheet.
Yeah, I think we would just put that in a separate sheet and, you know, basically have it its own section. So they can go back and forth between the two of them.
Yep. Any other questions, Casey?
I don't have any other questions, and I had my manager hop on. I think he's listening from another office there, so I just wanted him to see what the Opti-Haul is and understand it so that when he gets questions from our clients that he can answer them.
Yeah, no, I think it's good. Sorry, I've been just sitting here listening in the background. So I like this last deal you kind of went through here. That was my big question, is whether or not we could produce some of these graphs and stuff and provide them to our clients. I think this will be a big piece of information for them.
Good. Well, I'm glad it's useful. And if you have any other questions, let me know. And I did send Casey a link to another video where I went through this about a year ago. So it may have a slightly different flavor. This video that we're creating right now, I'll send to you guys. And we'll, as I discussed with Casey, we may want to post it ourselves. And what we'll do is we'll kind of go through it and clean it up a bit, and then let you look at it for the final okay as to whether we post it or not.
Sounds good to me, David.
Great. Well, it's been a pleasure.
I appreciate your time. Have a great day.
Okay. Bye now.
All right. Thanks. Bye.